Hello everyone, and welcome to the IPCEI ME City first webinar. Today we will discuss the importance of the important project for common European interest, IPCEI, in microelectronics and communication technologies, ME City. We need an IPCEI ME City now more than ever because it can help Europe maintain its technological sovereignty and foster innovation in the semiconductor ecosystem. Over the next 2 hours, we will hear from various experts on this topic. Before we start, I want to remind everyone that you can ask your question for the YouTube chat. We will address this question at the end during our dedicated Q&A session. So let's start by outlining the purpose of today's webinar and our agenda. The main goal is to understand the significance of IPCEI MECT and its impact on Europe's technology sector. We will have insightful presentations and discussions from our distinguished speakers. Additionally, we encourage online interaction, as I said, through the YouTube chat and comments. So allow me to introduce our speakers for today. First, Nicolas Gouze, senior consultant at VDI, VDE Innovation and Technique GmbH. We will bring greetings from the German Federal Ministry for Economic Affairs and Climate Action. Then we will have the Professor Stefano Selleri from the European Commission DG Communications, Networks, Content and Technology, DG Connect. We will speak about the importance of IPCEI for Europe's technology sovereignty and promoting innovation in the European semiconductor ecosystem. Then we will have Ferdinand, Head of Public Collaborative Programs at NXP Semiconductors, and Martin Strasbourg, Director at Workstream Group. We will introduce the IPCEI Workstreams, Sense, Think, Act and Communicate. Patrick Pype, then, the Director Strategic Partnerships at NXP. We will present key information on the Sense Workstream. Then Sandra Eger, Innovation Manager at ATS. We will present the Think Workstream. And Cosimo Musca, Deputy Head of Italy Public Affairs and Programs Management Director at IPCEI Microelectronics. We will present the ACT Workstream. And finally, Baeder, Director International Relations, ITU UN at Roth & Schwarz. We will present the Communicate Workstream. And finally, I am Clara Pavlak, the IPCEI Communication Leader at ABGI. Today, I am stepping in for my colleagues Mireille Terver, the IPCEI Program Leader at ABGI, who unfortunately couldn't join us. So I have the pleasure to be your host today. And now I invite Nicolas Gouze from the German Federal Ministry for Economic Affairs and Climate Action to welcome us all officially from the IPCEI MECT coordination team. Hello, Nicolas.
Hello, Clara. Thank you very much. A warm welcome also from my side to all people hearing us in live and also in the recording afterward in YouTube. I'd like to make some general introduction about the important project of common European interest on microelectronics and communication technologies. In short, as you said, IPCEI MECT. My name is Nicolas Gouze. I'm working at the German funding agency implementing the program at national level on behalf of the Federal Ministry for Economic Affairs and Climate Action. And as representative of the coordinating member state, I'd like first to thank all contributors to this webinar. At first place, the facilitation group and the transformer group, but also, and most importantly, the team behind the camera, Clara, you, Diane, and Mireille, and all your colleagues at ABG. You've done a great job, a very professional job in organizing the webinar. But coming back to the core of the IPCEI, the IPCEI scheme is actually considered by member states as a very effective instrument to tackle the pressing challenges that Europe is facing in terms of geopolitical, economic and technologies. The IPCEIs generally speaking, leverage massive investments which are crucially needed to strengthen the industrial position of Europe in the global competition, and to make a strong contribution to Europe's future innovation capacity and resilience. It is crucial to bridge the gap in the value chains and from lab to fab, and to support the first industrial deployment beyond R&D. And that's why state aid is actually needed, and the IPCEI provides a legal framework for member states to provide financial support to that. Maybe a short history. You may remember that it all started with a joint declaration of member states in 2020, in December 2020. Then started a design phase, which ended in last year in 2023 with the approval from the Commission in June. I don't know if, yeah. Well, it's important actually to remember that this IPCEI is probably the largest IPCEI that we have for the time being, because of this geographical representation. We have 14 member states with direct participants and other participants, 6 with associated participants, and 7 further members joining the ecosystem as indirect participants. So that's a real European effort, which is also covering the whole value chain. So we have really representative of all position in the value chain, and beyond serving large enterprises, I'm quite glad to see that we have a substantial proportion of SMEs and of research organizations. In terms of content, with the 4 main work streams developed in the IPCEI, we are covering the basics and crucial functionalities of electronics. We think, sense, act, and communicate. Well, big challenges means also significant means. And I think it's very important to state the fact that 60% of the total investment are done by the beneficiaries, by the private sector itself, and 40% is done by public authorities. And this financial setting, and combined with the objectives in terms of spillover generation, in terms of emergence of new technologies and innovative products, and combined with responding to market failures, are at the core of the motivation to set up the IPCEI in microelectronics and communication technologies. And that's important to state that for the member states, because they are responsible for the implementation of the IPCEI, and to reach also the objectives which were actually set up together with the industrial partners. Well, that said, I'm glad to introduce the next speaker, or basically the next video from the European Commission. And I'd like to thank the European Commission for the constructive support and collaboration. And Professor Selleri sent a video, I guess. Huh?
Yeah, exactly. Thank you, Nicolas. So, as you said, next we will hear a recorded message from Professor Stefano Selleri from the European Commission, DG Connect, DG Communications, Networks, Content and Technology. So he will explain, as you said, to us the importance of the IPCEI for Europe's technology sovereignty and promoting innovation in the European semiconductors ecosystem.
Good afternoon to everybody. I'm very happy to be here this afternoon, not with you physically, unfortunately. but I would like indeed to thank the organizer for having invited me and to have this opportunity to show you how important are IPCEI for the European Commission and how indeed they could impact the Europe and its economies. So let's go to a first slide where I would like to stress the most important characteristic of the IPCEI is that just to give you a little of background and let you understand that IPCEI are not, let's say, standard project like projects that could be submitted by single companies or single consortia. But this is a very large integrated cross-border project. IPCEI indeed involves many member states and many companies, and we will give some data about this related, for example, to this IPCEI. You know the data, but this is indeed an important point. Another important point is related to the market failure. IPCEI should be able to address important market failure we have in our economies, and also should be able to provide innovation. Real innovation. So the focus on research, development, and innovation and first industrial deployment is indeed a way to address new market failure and define a new solution for that. Another important aspect is related to the spillover, because we expect IPCEI to benefit not only the member state and the economy of the member state participating to this project, but to let's say a wider part of the European Union. So we will touch upon this different part of the this characteristic in the different part of the presentation. So very quickly, a bit of general overview about the IPCEI, because this is just to provide you some information about how important are IPCEI for the Commission and for the Union itself. I mean, we have approved different IPCEI on battery, cloud, health, hydrogen, microelectronics, and so on, as you know. And this means, if you want to give some numbers, that more than 300 projects has been proposed by almost 300 companies across Europe, and starting from 37 something more state aid approved, more than 66 billion euros has been unlocked through 22 member states. So these are big numbers indeed that prove themselves how important our IPCEI can be, how IPCEI can be important for our economies. Going specifically to the IPCEI Microelectronics, let me give a very, very short background on what has been done before this IPCEI we're talking about today, because the first IPCEI Microelectronics started in 2018, and it is actually not completely finished because we have still one project, a few projects, maybe just one project running in 2024, and it was built up by actually 4 and 5 member states with 32 participants. It was structured around 5 technology fields, very important for the semiconductor area, and these were in particular energy efficiency, power semiconductors, mirror sensor, optical equipment, and compound materials. And the IPCEI, this first IPCEI, has indeed achieved important technological breakthrough in these different fields that are somehow a starting point for part of the activity of the new IPCEI. The new IPCEI on microelectronics and communication technology we are talking about today is as a long story, starting back in 2021 with pre-notification of member states, and with the assessment going on through all the 2022 and part of 2023, resulting in the final notification by 14 member states in April 23, with the adoption and decision of the decision in June 2023, of course. Now, just to give some data, once again, as promised, but you already know that we have 14 member states participating, plus other 6 more other participant member states. Sorry, the 14 member states actually participate with direct participants. These are 56 companies, and we have also 30 and plus associate participants, around 600 indirect participants, and for this IPCEI, and just for this IPCEI, we have 13.7 billion of private investment supported by more than 8 billion of public investment. These are the projects presented. And by the different member states, as you can see, we have a rough nice distribution across member states, of course, with some countries with which have a bigger footprint in this particular sector. And the structure of the IPCEI is like this one. We will you will go through this different work stream during the day, and more or less this structure mimics the behavior of a human body, where you have to sense and understand what's happening around you with a particular sensing technology. Of course, you have to think and to elaborate on data you are collecting, and then act accordingly. Communicate, of course, is the important, let's say, framework that allows all the different steps to behave and to act. The project has important targets. I cannot enter into the detail of all of these targets, but just to give you some spots: strengthening the sovereignty and the resilience of the EU ecosystem, for example, by reducing structural technological dependencies in different positions, in different technology areas along the semiconductor value chain. Another important point is addressing the Green Deal by reduction, for example, of the energy consumption, and supporting the digital transformation, and the developing standard for data and cybersecurity, and so on. These are important targets of this IPCEI that are perfectly in line with the policy of the Commission and the policy adopted by the European Union. And this is an important point, because this is a way to support and to work all together, Commission, Member State, and companies in the different ecosystem. I was talking about the semiconductor value chain. Indeed, this project, this IPCEI, is addressing the different sector of the value chain, starting from the very first design of chips, the selection and of materials, and the front end, back end fabrication, and so on. So this is indeed, let's say, a design of a project that fully addresses the full value chain in microelectronics and communication engineering. This means that actually, even talking about important markets we have in Europe, we can indeed say that the IPCEI is completely in line, let's say, with the development of this market, talking about telecommunication, mobility. This is not just automotive, but even something more. Biomedical and health are very important, energy, and with particular focus also on artificial intelligence and quantum computing technology, that are important technology already in the present, even more in the future. We were talking about spillover, so I would like to focus a little bit about this. You know, we are expecting this IPCEI to create something like 8,700 more new jobs, and this means, for example, that companies and universities, and in general all the educational pipeline, has to work together to define new approach and new let's say new approach in order to tackle this problem. So the numbers that you see about the collaboration between universities and companies by supporting PhD studies, master theses, internships, or even university chairs are important numbers that could have not been possible without this particular tool. So indeed, this is an example of a particular spillover that can be indeed very important. In conclusion, let me say that I do believe that this IPCEI can help the European sovereignty in semiconductor, and are indeed, in general, IPCEI are indeed important tools that bring together knowledge, expertise, resource, actors across the union, and this is an important added value for the union. Let me finally say that the Commission, of course, is committed to follow very close the development of the IPCEI, and we are also already working in streamline all the process from the very beginning, from the design up to the implementation of the IPCEI, and indeed we believe that this instrument can impact the economy at a very high level, at a very high extent. So with this I conclude my presentation. Thanks a lot for your invitation, and I wish you a good work for this afternoon. Thank you.
Thank you. A very clear message from Professor Selleri. Thank you. So to dive a bit more into the details of the IPCEI ME program, Ferdinand, Head of Public Collaborative Programs at NXP Semiconductor, will introduce the IPCEI Workstreams: Sense, Think, Act and Communicate.
Thank you so much. Yes, together with Martin Strasburg, I lead the facilitation group representing 700 direct, indirect and associated partner in this huge program. We represent this big team to the public authorities of 27 European countries, so a lot you can see. And we lead also the Workstream sub-teams. Later on you will see what a fascinating, great team this is. For the next couple of minutes, I will try to introduce you to this IPCEI program and see, hopefully you see what a nice, beautiful project we have here to manage. A bit of motivation, and Nicolas already talked a little bit about it, but I want still to highlight 2 or 3 things here. And of course, we have to show that the European value chain is positively impacted by this huge program, that we follow the political priorities of the European Union, and we have to know that this program is complementary to the R&D programs, that we address critical key enabling technologies, how we call it, and it's funded by the national authorities. And this is an exception, actually, this IPCEI. Why? Because it's an exception to the state aid rules we have in these days. We basically have to address high-risk projects. This means high-risk projects for the companies. And since the volume is so big of this IPCEI program, we must show and prove that there's a big value for the European industry and also for the society in general. And I would like really now to start with the first highlight. And the first highlight is that we analyzed yesterday, the first KPIs of this project for 23. And one KPI is to hire people. And we have the overall goal to hire 9,000 people for this whole project. But with the end of 23, we already have hired more than 4,000 people in Germany, Netherlands and France only. So there are even more people hired during this project duration up to now. So it's a big, let's say, cool highlight already now, today. Yeah. So the IPCEI, what is it at a glance? It's a 22 billion euro program. It's the biggest IPCEI ever in Europe, and with a 8 billion euro funding and a 14 billion euro private invest. So a huge program. The first IPCEI, just to remind you, was only 8 billion, and we had here 32 companies in 5 countries, and we have now 700 companies in 27 countries engaging in this project. So it's really a huge, big, great thing. So what is the difference between the first IPCEI on microelectronics and the one we have now? The first one was really focusing on the pillar 5 of the strategic pillars of the European Union, which was to increase the manufacturing footprint in the European Union. Our scope is much broader. Our IPCEI on microelectronics and communication technologies has also to focus on the digital transformation, on the Green Deal, on the increase of the resilience in data and cybersecurity. And we have to reinforce the value chain to increase in the European Union the resilience and sovereignty. So you see it's much broader, this scope of this second IPCEI. The next page now shows you basically the framework of this IPCEI. And you see that it's a quite big framework in terms of that we have 4 work streams in there. The work streams are called Sense, Think, Communicate, and Act. And you find the definition and the description of this framework in the chapeau document with 700 pages thick chapeau document notified by the European Commission a year ago. And in there you find the definitions of all what we have to prove and what we have to follow. Before I go a bit more into detail, I really like to highlight that this chapeau document is the basis for all of our projects. What does it mean? We wanted to enhance the microelectronics value chain in this project by having more value, more, let's say, more positive impact for the society than we had in the past. And we all together work on that, and we can only achieve this goal by collaborating together. So this is one big achievement here for this IPCEI, that we collaborate in this huge program together. Later on, there will be much more details on how we do it. 2 examples why this second IPCEI is mandatorily needed, because we had the first 2 IPCEI, and which is actually still running, and now we have the second one. Why? I give you 2 examples. The first example is about autonomous driving. I go now back into 2016. 2016, there was the first big, let's say, hype on artificial intelligence. Newspapers were sending out articles saying, look, a great AI will solve all the problems, and in 4 years, which is 2020 at that time, the new vehicles will autonomously drive, autonomous driving vehicles. But then 4 years later, 2020, we all know there was a big disappointment because this did not happen. And the newspapers sent out articles saying, look, you techies, our whole community, you techies basically, you overpromised and underperformed, underdeveloped. And so we basically were wondering what is the reason why. And indeed, we did a fundamental error. And the fundamental error was we did not put trust, security and safety into the ecosystem. And now the good news, in 24, now today, we start with IPCEI to change the ecosystem fundamentally. What means that many companies in this project, in this program here, now work on solutions, on projects to improve, to enhance the sensors, to have more intelligent processors based on artificial intelligence, for example. We also strive for minimum latency in the networks, and we have a more secure and safe actuation. What this means is that at the end, I'm personally convinced that with this project we strongly support the introduction of autonomous driving during the next years, and a European Union, we will have a leading role in there. Second example is the communication. The transition from 5G to 6G. Basically, the 6G is the next generation for communication, which has to achieve 100 terabits and latencies of 100 microseconds, 50 times higher data rates and a tenth of the latency. How can we achieve it? Well, we can achieve it when we work today now on the solutions, on the hardware and software. And this is something we do now, although 5G is only ramping these days. So why is this such a challenge? Because the frequency ranges of above 100 gigahertz we have to apply, they basically have never used for the communication, for the mobile communication. So we really have hard to work on it. And the European Union, again, and they invest in this activity. They want that the 6G will become the leading technology in Europe, so that we basically drive this communication to the benchmark, basically. And not to forget, 6G will help the key industries in Europe to further grow and to be competitive. And the key industries like industrial 4.0, like health, like automotive, they are, of course, they will benefit from this development. Again, I'm very convinced personally that thanks to this IPCEI, we will do a huge step forward.
Thank you, Ferdinand. This is very interesting. I guess you will present also the next speaker in your next slide, like the full team of the IPCEI.
Yes, if the next slide will stop here, then you should see now the logos, the 60 companies who are direct partners, and this is something really remarkable. 60 companies that are involved in this IPCEI as direct partners, and with this, let's say, high-level, powerful companies, I'm again convinced that we achieve our targets. And who will support this whole program? And the next slide shows now the team of the facilitation group. And you see here with Thomas Fleischmann and Patrick Pype taking about the sense. Gerhard Döll and Sandra Eger Think Communicate is managed by Uwe Baeder and François Brunier. Cathy Bardisson takes care about Act together with Cosimo Musca. And Stefan Defreger and Alain Filipowicz about the important spillover effects. And Martin and myself, we try to make this whole thing together happen. So thanks a lot, and I hope this introduction helps to understand a bit the whole thing here.
Yeah, I think so. Thank you. So now let's hear from the workstream leader what is going on in their specific workstreams. First up is Sense, presented by Patrick Pype, Director of Strategic Partnership at NXP. Sorry. So Patrick, you can switch your slides. The TV is a bit shaking, but it should work.
Okay, that's it. Thank you very much. Good afternoon, everybody, and I'm happy to present the Workstream Sense, which I'm leading together with Thomas Fleischmann from Bosch. And so I would like to give you a short introduction of what we are doing and what does Sense mean for our program. So the Workstream Sense, in fact, has the main goal to capture information from our environment. And we need this information in order to have it processed for decision making. That's happening in Workstream Think. To communicate a decision, that's happening in Workstream Communicate, and to act upon that information, which is happening in the Workstream Act. What we do here is really work throughout the whole value chain, from materials, processes, tools, up to the next generation of sensors for different types of application. And this includes also specific features. Ferdinand already indicated security, safety, which are of crucial importance for health and automotive, for example, mobility, embedded AI, new functionalities, novel memory concepts, etc. And as stated, it all will be applied in different application domains. Just to make a comparison of what Sense means, it is in fact this is the slide I was looking for. It is in fact capturing the information from our environment, and you can compare it with our eyes, our ears, our tongue, our fingertips, and our nose. Because sensors, what do? They are hearing something in the environment, they taste something in the environment, they see what's happening in the environment, for example, radars in automated cars. You can feel the fingerprints, and they can also smell, for example, for environmental monitoring. And here you see some examples. On top you see the autonomous driving car. In the middle you see environmental monitoring. You also see health. And just to give you an example, in a smartphone there are more than 10 sensors to capture all type of information. In the engine of a car there are typically 20 to 30 sensors. In the whole car there are around 100 sensors dependent on the type of car you buy. If you look to a Formula 1 car, there are 600 sensors, and in an airplane there are more than 10,000 sensors. So you see the whole of our applications do contain sensors in one or another form. Also in the football, they use sensors, but I know this is quite sensitive in today's environment, so I will not talk into detail on this type of sensors today. But let me switch to the next slide. There you can see the different participants in the Sense program. A lot of companies in Germany are involved, 9 in total, 3 in France, Romania, and Italy, and also in other countries like Ireland, the Netherlands, Poland, Czech Republic, Austria. There are direct partners involved in the cooperation of the program. On the next slide, we see the value chain, where you indeed see that sensoring is mandatory for, in fact, our electronic systems. And here we work on materials, tools, as you see on the first picture, new types of materials for future sensors. The second part is on the semiconductor technologies, smart manufacturing, new types of integration, system in packages, etc., especially focusing also on high reliability. The third is the components and the modules themselves, so the sensors themselves, which can be of different nature, and where we have the conflicting interests of having always higher performance, but always lower power and at an affordable cost. And then at the very end, of course, you have the total systems which are built into the different cars, airplanes, MRI scanners, etc. So now on the next slide, you see how the Workstream is implemented. And you see we have 4 work packages, which are similar to the 4 elements in the value chain I just showed on the previous slide. And you see the specific challenges. So secure critical materials, tools and equipment is in work package 1 a key challenge. In 2, it's quality, reliability, recycling, cost effectiveness in manufacturing, packaging, characterization and test. Then in the third work package, all words which are mentioned here are of key importance. It should be smart, it should be highly integrated, robust, reliable, advanced, intelligent and trustworthy for single and multi-sensor components and modules. And of course the fourth work package is to show that the sensors can be used in different types of systems. So then the next slide, we see the participation on collaborations, and in total we have 133 collaborations in our workstream. Within the workstream 62, inter-workstream 71, which are equally shared amongst the different other work streams like Act, Think and Communicate. And furthermore, we have 200 collaborations with other type of indirect partners. So I can only conclude by saying on the next slide, everything what do does make really sense in our work stream. Thank you.
Thank you very much, Patrick. So while my colleagues maybe can search for another TV, let's hear what is going on in Think, presented by Sandra Eger, Innovation Manager at AT&S, Austria Technologies and System Technique. And I don't know how to pronounce the last word, to be honest, so please, Sandra.
Okay, thank you very much for your nice introduction. So, good afternoon to everyone. My name is already mentioned Sandra Eger. I'm working for AT&S since 2005. And together with Gerhard Döll from Zeiss in Germany, I lead the workstream Think. And today it's my pleasure to introduce you to that workstream, to the Think workstream, and give you some insights. So, what is Think? Think addresses the microelectronics value chain of energy efficient and secure data processing and data storage at all levels. This means in particular, we talk about materials, software tools, equipment, front-end, but also back-end technologies, packaging technology, chip design, and also the fabrication, and of course, the applications which are enabled. Think covers a wide range of applications, from automotive to other industrial applications, communications, security, health, and so on. So, and Europe is a leader in materials and equipment, and has also expertise in chip design and manufacturing, as already mentioned, in particular in RF, embedded memory, power and sensors, and all these to achieve a lower power system-oriented approach. And components for greener, safer processing are needed, and for that the system approach is essential. So now we have clarified in general what is Think. So now the topic will be, or I want to show you who is Think. So now we have 42 direct participants in the workstream Think. That's a really a broad spectrum of partners from all over Europe, and almost half of them are from Germany and from France. So, and they include big names or big company names like Bosch, Infineon, NXP, and Continental, only to name a few. But many other nations are involved in the Workstream Think and in the total IPCEI ME. So we have also involved companies from Romania, Greece, and Italy. Only to name a few, so it's not possible to name all here. In addition to the direct participants, we have 10 associated participants or partners who are also working and sharing their expertise as part of this workstream. And so it will be exciting to see what great things this whole project, this workstream, this concentrated knowledge will produce in the next few years. So, what are the expected results? Like the entire IPCEI ME framework, the Think workstream includes a large number of technologies, and the expected key results beyond the state-of-the-art materials and beyond the equipment, and also advanced technologies, like, for example, tools for developing FPGAs in the Workstream 1, in the Work Package 1, the materials and tools and equipment. Then organic substrate for low volumes is a focus in Work Package 2. We have the planned result or the expected result of automotive grade processor in 5 nanometer design in Work Package 3, and in Work Package 4 the subsystem and systems. We have a result or a planned result for digital twin, where we work on software and virtualization techniques. So that's a similar slide as for the Workstream Sense. It's the same structure, I think, for all the it's for all the workstreams. So within Think, the goal is to develop and deploy the latest generation of digital front end and packaging technologies, chips, and systems to keep Europe in the leading edge of this enabling field. And therefore we will develop and apply the latest families of materials, equipment, and tools to support these objectives. And this aims to keep Europe at the forefront and of innovation. The target is broken down into 4 different work packages. So we have in the Work Package 1, the material simulation tools and production equipment. Here Think focuses on material simulation and production equipment for the semiconductor value chain, for focusing on digital technologies. In Work Package 2, the semiconductor technologies, smart manufacturing, packaging, and test. Think faces challenges involving high reliability, reducing dimensions, increasing throughput, and maintenance cost effectiveness as standards in manufacturing. Also focus on packaging and characterization and test. In Work Package 3, the components and modules work package, this work package deals with groundbreaking techniques needed for various applications for power efficient devices. So they deal with techniques and architectures, cores, memory technologies for a variety of a huge amount of applications. And last but not least, the Work Package 4, the subsystem and system work package, aims to industrialize building blocks for vehicle computer and controller, high-performance computing, and other systems involving artificial intelligence, 6G, and the latest standards. And here it's to say that integration is a key to achieving seamless functionality and performance in a complex system. So the last topic I would like to present is who works with Think. So within Think we have a living network of collaborations that drive the innovation or the mission or the objectives. So we have 150 planned collaborations in total where experts work closely together, and 80 are planned within the Workstream Think, and 70 collaborations are planned cross-workstream collaborations, evenly split between Act, Sense and Communicate. And in addition, Think continues to expand its reach. So there are more than 220 collaborations planned with the broader IPCEI consortium. So we talk about indirect partners, indirect participants, where we also work closely together. Okay, Think, thank you very much.
Thank you, Sandra. So as in the human body, as you said, upon sense and think, it is time to act, which is presented to us today by Cosimo Musca, Deputy Head of Italy Public Affairs and Programs Management Director at ST Microelectronics. Welcome, Cosimo.
Good afternoon, good morning. Thank you for the invitation. Thank you for the opportunity to talk on behalf of the Workstream Act. The Workstream Act, just to talk about the technical activities we are addressing with the Act, and also with the contribution of the entire community involved in the Workstream Act. I'm the leader of the Workstream, but there is also the key contribution and participation of Cathy Battiston, Renault France group, a group in France as a leader of the Workstream. Always we say that there is a coordination among the different work streams. Clearly, we are very proud to say that the role of ACT deals mainly with power and actuation. The aims of the Workstream is to do something with the analog and digital information and have an effect. This effect can be of different nature, managing energy flow, displaying, moving or adjusting something, driving an electrical motor, or several different actions. We are at the core of the entire IPCEI Microelectronics and Communication Technology Initiative and Program, and also with an integrative nature we serve the other work stream, because the other work streams need the enabling effect arriving from the Workstream Act, the power sources and also the actuation role. By having an effect, this user-oriented Workstream contributes to the global reduction of energy consumption. The role of Workstream Act is important not only for the entire microelectronic industry, but for the whole power conversion value chain, because the green transition and digital transformation clearly lead to an enormous development of electrical power conversion applications. There is a huge need of efficient power electronics in many sectors, such as the renewable energy, the smart grid application, the stationary storage, the data centers, the electrified mobility, but in general the electrification of society, I will say, and also the industry, and also the big impact induced by the diffusion of the Internet of Things, or the industrial Internet of Things, and the interest to apply artificial intelligence in a different application. This kind of sector or vertical application, they need high blocking voltage, low power dissipation, high switching frequency, and the Workstream Act will address activity related to this specific field and domain. Which are the key objectives and the challenges of the Workstream Act? The key direction of the Workstream is to introduce and deploy the latest generation of semiconductor to achieve the beyond state-of-the-art, sustainable, efficient, high-performance product for semiconductor products for the application in downstream market in the downstream industry. The Workstream Act addresses the four work packages. In particular, the first work package is related to material, simulation tools and production equipment, and the objective of the Workstream is to secure critical material and equipment for the semiconductor value chain. In the second work package, we address activities on the semiconductor technologies, the smart manufacturing, the packaging and the testing activities to reach high level of quality, reliability, recycling and cost effectiveness. In the third work package, we work on components and modules with a clear target and KPI in terms of reliability, energy efficiency and sustainability. And then with the fourth work package, we address subsystem and systems just to meet the requirement of the downstream industry in terms of efficiency, affordability, reliability, and the environmental footprint. All this is done just to ensure to reach the supply chain insurance on behalf of Europe, its industry, and the world society. The participation and the involvement of different member states or different direct participants. We have in total 25 direct participants in 7 different member states, and we have also the participation of 9 associated participants in 7 member states. There is so we will talk about the community of Workstream. It's a huge community, a very large participation in terms of companies and member states. The participation of the direct participants is well distributed along the whole value chain or the different challenges addressed in the 4 work packages. And the key results that we plan to reach as expected with the developed technologies, the addressed products, semiconductor products, and the final systems is clearly to go beyond the state of the art in terms of semiconductor materials, in the field of manufacturing equipment, in the technology platform both on silicon or wide bandgap materials, mainly on silicon carbide and gallium nitride, other advanced material, also the piezoelectric technologies, the micro LEDs, and develop new electronic devices, as well as the energy efficiency and the application-oriented microelectronics system. I told before about the integrative nature of the Workstream. We see also the impact of the Workstream in terms of collaboration. We have a total of 112 collaboration. Part of this collaboration is inside the intra ecosystem of Workstream Act with 73 intra-collaboration, but also we have a cross-Workstream collaboration because we provide the other Workstream need energy sources, need the actuation effect arriving from ACT. So we have 39 inter-Workstream collaboration, with 17 with Sense, 18 with Think, and 4 with Communicate. But the impact of the Workstream goes well far beyond the ACT perimeter, let's say, because we have also a very huge number of collaboration, about 150, with a broader perimeter of participants in the so-called area of the other indirect participants. That's why I would like to close with our community claim. Let's act together to reach the results addressed by the Workstream Act. Thank you for the invitation. Thank you.
Thank you. So finally, let's hear from Communicates, presented by Baeder, Director of International Relations, ITU UN at Rohde & Schwarz. Welcome, Uwe.
Yeah, thank you very much. It's great to be here and to present our Workstream Communicate. The Workstream Communicate is led by François Brognier from Soitec and myself. What is Communicate about? So Communicate, we define a little bit ourselves to be in that picture as the pathway to the nerves of the nerve pathways, which connects the brain and all the other different work streams that we hear with sense, act, and think. Communicate addresses microelectronics mainly for the communication part, and this is very important, as we see that this is all together interconnection of all the different work streams that we have here. We heard earlier, main goal is fast, reliable, and secure transmission of data, which is very important. We focus there on broadband, wireless, but also wireline connection, which is a key in our development. And so that is why we have a large range of areas that we address in this part. And this connects also to edge computing, digital twinning. We need to combine KI findings with all the different other work streams that we have here. So that is why it is very important to also collaborate with all the work streams there. The focus of Communicate is on innovative materials, design processes. We look into tools and the architecture and the algorithms for the next generation of communication components. We heard already today much about 5G and 6G, that this is the future development and very important for the overall digitalization in the European Union. And that is why we look also in increasing the bandwidth, again, wired and wireless system. Cybersecurity is a very important topic because no communication is worth if it's not secure. We reduce latency, as this is a key issue for many of the applications that we have to cater, and also make use of AI, new frequencies. We need to have novel approaches to DSP and also to address an overall higher performance while having a lower energy consumption. Yeah, on this slide you basically see the map of our direct participants. We have, I would say, a very good mixture of smaller, larger companies. We are with the Workstream Communicate in 9 different EU countries. We have 25 direct participants, and again, it's a great crowd. Personally, I remember we had a Workstream kickoff in February where we all together met, and again, this was already a very great event to get in contacts with all the colleagues from these different companies, and that we could reach for the higher goals of the IPCEI as a community, especially here in the Workstream Communicate. So what are our key objectives? Communicate, as mentioned, is committed to communication systems consisting of analog and digital receivers and transmitters. We look into novel semiconductor technologies, materials, also for the analog and digital and mixed signal components. Our playground, as also with the other work streams, is very similar. Materials, tools, and equipment in the work package 1, semiconductor technologies, smart manufacturing, packaging and test in the work package 2, work package 3, components and modules, and work package 4 for subsystems and systems. Specifically, we look into to secure critical materials and look into the design and manufacturing, secure, reliable, and cost-effective semiconductor technologies in work package 2, and of course looking into the higher frequency technologies. These are the key for when you look into the further development of 5G and especially for 6G. high performance, power efficiency, as outlined, that's part of our work, as well as this is addressing the Green Deal component of the IPCEI in total. And also, as we see more and more of these devices, we need to bring down the energy consumption to have the same or higher performance at lower energy. Yeah, at the end, we are looking into advanced radios, into complete communication systems, addressing this new generation of communication and the appropriate features and applications in the different streams of industries, and also together a lot with the collaborations of our colleagues in the other work streams. So we can break down that a little bit more if you like. We in the work package 1, we are looking into ADI tools and measurement equipment, substrates, and different materials. In the work package 2, we are looking into the technologies of these materials more directly, packaging as well, assembly and test of these. In the work package 3, signal processing, AD and DA converter, data processing, and power amplification of radio frequencies. And then finally, in the 5G and 6G complete systems, we are looking into optical radio subsystems, hardware, software co-design, cloud radio systems, and the handsets of the user. I think that is probably for all of us the most exciting thing, to get a shiny new handset and to have new features that you can play with in your mobile phone. You see also the direct participants are outlined there per work package. We like this slide exactly very much because you see a good mixture even in all the work package of smaller, of larger companies work together across the whole value chain. And this makes IPCEI so outstanding in my eyes, that we all work together with these common goals, but with, of course, a very good cooperation. Yeah, communicate. I would say communicate DNA is to cooperate, is to connect people, is to work together. So in total, we have 134 collaborations in the Workstream 78, and then the rest of, with all the different work streams, it's very clear that, as said before, we have a lot of these interconnections, as at the end of the day, we need to communicate with all the other work streams that we have in the IPCEI projects. Furthermore, we have also 287 collaborations with in the broader IPCEI community or consortium, also with associated partner, which is very valuable because this spreads the idea, that spreads the knowledge, the technology that we develop here in a larger scale, and that makes it, again, gives, or let's say, gives much more impact to the whole industry across Europe. Thank you very much.
Thank you, Uwe. Thank you. So we heard about many activities in the different work streams, but how does this affect the semiconductor industry and society? Alain Filipowicz, Innovation and Research Partnerships at Continental Automotive, will let us know how spillover activities are maximized across Europe.
Thank you, Clara. So we talked already of spillovers. So what are these spillovers? So first, they are defined, clearly defined in the communication plan of the program. In item 2, so IPCEI can make a very important contribution to sustainable economic growth, jobs, competitiveness, and resilience for industry and the economy, and later on, and with positive spillover effects of the internal market and the society as a whole. So you see the keywords. We talk about economy, society, jobs, competitiveness. The benefits of the project must not be limited to the undertakings or to the sector concerned. We will see that later on in several activities, but must be of wider relevance and application to the economy or society in the Union through positive spillover effects, which are clearly defined in a concrete, identified manner. So I will show you just after that. First, there are 4 categories that can be somehow, in fact, there's not just one category, you are in one or not in the other. First, we make the difference between IP and so intellectual property and non-IP dissemination. This means non-IP, it's mainly, I would say, open source, open communication. IP not protected, this means, for example, you will see communication when you are doing a PhD and things like that. And IP protected results, that's something else, because in that case, you are taking, for example, patents. That's one way to protect your IP. And these patents, you propose licenses to any kind of European enterprises. And here in the program, we have a front, so fair and reasonable, non-discriminatory conditions to offer to any enterprise that want to use our results of the direct and indirect participants of the program. And now the third category can be both non-protected or protected. It's during this famous FID phase, so I would say the start of the fabrication of what we have invented with our R&D. And then we mentioned that in the definition, we have to disseminate beyond the targeted sector. This means, for example, I am working in automotive. Okay, my result could be interested to naval activities, to aerospace activities, I don't know, or maybe defense also. So any kind of other sectors that are not usual to us, but that we have the that we must contact and so disseminate information. So and now I will show you the 18 spillover key performance indicators. So on this first chart there are 11. The 7 other one will be coming next. Here you see a lot of things. So I won't read them line by line, just to show you that 8 of them concern, I would say, jobs, students. So the contact with universities is something mandatory for us. Here also you see on the right there are 2 columns, without IPCEI and with IPCEI. That's in the definition of the program. We have all taken commitments to do things, to do spillovers, and if we were not having IPCEI, well, we would still continue to make PhD with universities, but much less. Also, when we are talking about events, that's something where it's organizer of external events. Of course, there are events in our own community, so automotive in my case, but there are also events for other communities, for other domains. That's where we will find the contact with other domains. Just to continue, licensing to companies. So we mentioned this on the front rules. Also research organizations, not only universities, because in Europe we have also research organizations, and this is very good. Also any kind of, you see IPR protected results in reviewed journals, and well, there are product design kits also, so things materials that you can manipulate. And of course, joint undertaking collaborations. I think in the panel maybe we will discuss about that. Mm-hmm. Well, I think that's all for spillovers for this small introduction, because we wanted to keep time for the panel now.
Yes, exactly. Thank you, Alain.
Thank you.
So as you said, we will now take a short break to adjust technically before our panel discussion. So please take this time to grab a coffee or stretch your legs. When we return, we will have an exciting panel discussion with our previous speakers on the impacts of the IPCEI ME city. So stay tuned. We'll be back shortly. Thank you. Okay, thank you for your patience. Let's start our panel discussion on the impacts of the IPCEI ME CT. Our panelists, who are the previous speakers, will discuss various topics, including technology highlights expected by the end of the IPCEI, the visible and expected impact on the European ecosystem, and how the IPCEI can spur more young people to enter the STEM professions. So welcome back, dear speakers. First questions, what are the key technology highlights we can expect out of Europe by the end of this IPCEI ME CT? Who would like to start?
Yes, hello. I can take this one, yeah. So I guess one highlight is certainly that for automotive, and you know, automotive is one of the most important industries in Europe, we will in this IPCEI develop a 5 nanometer chip. We will develop IP in Europe, and this chip will be, I guess, I'm convinced about it, be a kind of benchmark chip, because we will include artificial intelligence accelerators into the chip, so that that processor will be a kind of brain for our next generation cars. And this is something, I guess, which is really unique for Europe. And this will, again, help that the growth and the competitiveness of in the European Union will be more strengthened.
Okay. Anything to add from other panelists? Not really.
Yes, for example, in our project at Continental, we work on future architecture of vehicles. This means the vehicles of tomorrow will be completely different, and we work on that. So you eliminate a lot of computers. You make big computers within big network, so less cable, much better for environment.
Yeah, maybe also to blend in a little bit from the Workstream communicate, of course, is that we think IPCEI will have an impact on the development for the 6G. This is targeted to happen in 2030, so we are well prepared with the IPCEI to do it now, to look in the technologies which are key, and also to work together with other areas, especially also the other work streams. So if you look into the 6G, we have one topic that's called joint communication and sensing. And this fits very well into what we do with sensing, for example, that we work together, because I think there will be a lot of, I would say, common parts that we need to address. There will be a lot of synergy that we can mine from working together. So that will be a key as well. And so for that, I think that will be also one of the main outcomes.
Maybe I would like to add to this one that we discussed the technological impact, which is very important, but also the societal impact. If we have this new generation of cars, there will be much less accidents. And I think we all aim for the zero accident type of future. I think we are on the way to do so if we build the type of technology which my other panelists just discussed.
So I think we are kind of moving to the next question. As we talked about technology, the second question is, what are the already visible and expected impacts of the IPCEI ME CT on the European ecosystem? So anything to add about this? Yes.
Thank you. It's clear that just to be here today, to talk on behalf of our direct participants, the different partners involved in this very huge and large second IPCEI on microelectronics and communication technologies is a very great example of how the competences, the skills and the technology ability that of the European companies linked together along the value chain, from materials, the development of equipments, the development of the front end, the back end, the testing technologies, and just to serve the downstream markets. We were talking about automotive, but the challenge is to serve the societal needs in Europe. And really, we are at the end of the first 2 years of the project. We are reporting the results and activities with a very huge number of activities, results, partners involved. I really believe that with this second IPCEI, we are increasing the level of challenge, and we have created a real ecosystem in Europe, involving the different partners in the different role along the value chain. And in the next year of activity and results, we will show to the public authorities, to the European community, to the world community, that we are acting on behalf of the 4 Workstreams participants with a real focus and impact on behalf of Europe. This is what I believe, and really we will address this challenge.
If I may add to this one, I sometimes say the IPCEI program, it's like a Spider-Man or a Spider-Woman. We are starting to wave a web over Europe. And as you know, this takes time. And I think we are now in the stage where we started to know each other, where we started to define exactly what we want to do. And we know very clearly now what to do. And this is happening in next years to come. And so we will have a web over Europe between the industrial stakeholders, the RTOs, the universities, also the schools. I think this is important that we are really having this whole community, this big community, and not just small-scale type projects, but the whole community thinking the same and working towards the same strategic developments.
Nothing more, okay. So you are good at transition actually, because the last question is about discussing the future. So the last question of this panel discussion is, how can the IPCEI ME city spur the interest of more young people to go into STEM professions?
So maybe I will start. So have you seen when I was presenting the spillovers, we have a lot of them that concern students. I'm talking about, for example, internships. I'm talking about our engineers of our companies intervening, participating in masters in university and engineer schools. Also having a PhD, conducting work for us in both, I would say, academic view to obtain a thesis. And well, all of this is a way to attract, of course, students to our problems in our overall industries, partners of the program. And you know, for example, we like to have internships because that's a good way for us to recruit people. But that's not only the only way to interest students. So maybe, Sandra, you have something to say.
Yeah. So maybe as example, because Gerhard Döll, the leader of Think, couldn't join today because they have this week a summer school, and we are optimistic because they organized this summer school with 60 participants, and there were more than 150 participants are interested, and they have to really reduce because there was not so many places available, but we are optimistic that this is the right way and that there is some interest from the young people. And also, so we had a few weeks ago, we had in Austria this event Lange Nacht der Forschung, long night of the research, and here we see also a lot of interest of young people, and they are come and visit. So we are optimistic that we can make really impact.
Yes. Yeah. When I'm looking into the portfolio on technologies that we are addressing with the IPCEI, I think we have the latest stuff that young people are interested in. So we are addressing KI, quantum technology, new communication types. I think that is all that is quite intrinsic, and what we see also when talents are coming to us is that they want to work on projects which do have an impact, which also have the goal to be eco-friendly, to contribute to the Green Deal, to contribute to a better life. Social aspects are very important, and I think that is somehow that we have as fundamental goals as well, beside the technical story. And all that is mixing, and I think, into quite a good story for young people to enter exactly this type of economy, to enter those companies that are in the IPCEI and make this impact that the IPCEI has in its DNA. And so I'm pretty confident with all the spillover activities that we do, for example, internships, but also PhDs and so on, that we can transport this activity into their lives, into their work. And at the end of the day, you also need to make your life working. You need to earn money with your job, and I think this is also then the perspective that we can give. These are the future technologies. They will carry you on, and we need you with your ideas to contribute, and you can make it happen. And I think this story we can transport very well in the IPCEI.
Really inspiring.
A very interesting discussion, and also when we talk about how to raise the interest of the new generations. It's clear that we have the education with different level of students, but also we need to do a better effort to involve the different students also at the early stage level of scholarity or scholarships, with giving them the opportunity to touch electronics with demos, boards, just to show what does it mean to have a component integrated in a PC board and so on, just to allow the functionalities they can deploy, the different use, the electronics with board, the training kits, with educational kits. I believe that we have an integrated project portfolio, but in terms of technology to be developed, the components to be released, but we have also a very, very big program and challenge in terms of spillover actions. Inside the spillover action list, we have also this part of the activities devoted to involve the students in hackathon challenges, development of demo, distribution of design kits. This is a mission of our companies participating to the program, and this is a very big input and push to generate interest from new generation. They need to touch and see the electronics, the microelectronics, the things we do every day, all the time. They need to learn about us, and also they need to learn that, if I can add something, more and more we talk about deep tech technologies and topics, artificial intelligence, blockchain, and so on. We apply and we use it to apply this to hardware. So we need to show to the new generation what does it mean to apply this in an hardware platform and so on. This is our world. And we must become also the world of the new generation.
Thank you.
Maybe also one very simple example about home and about digital homes, and what will happen, and this will happen soon, because in our home world we have now established a standardization based on Meta. That's including Google and all these big companies who are referring to it. And what you can do here is, and this is I guess also exciting for the young people, you can save energy. How can you do it? You have, in the best case, you get the solar energy. You have this in your house, in your home, and you use that power for young, more not for me, but maybe for the younger people, to dry your hairs. And so it's a 2,000 watt machine, the hair dryer. So what could you do? You could basically switch off the refrigerator because it's still cold enough in the refrigerator. Use the power instead to go to the hair dryer and save energy. A very simple example, but this is only one example out of many. If you do intelligent electrification at your home, and this should or will be a big move for the Green Deal, what we just have discussed. Small example, but that's how it works.
Okay. Anything to add before ending this panel discussion? Okay. So thank you to all of you, our panelists, for this discussion. We have actually opened the floor to questions at the beginning of this webinar from the audience. So our team has selected questions earlier from the online chat. So I have a few here. We can start with them and see if there's other ones after. If your question is not answered, we can answer in the comment, for example, later on. So the first one I have for you is, I am working on semiconductors and I am looking to collaborate with expert partners. Can I get in touch with the IPCEI MECT participants?
The answer, sure, is yes. The IPCEI Microelectronics and Communication community is an open community, an open ecosystem. We are involved with the different competences and skills. Also, we are now improving the website, the channel to communicate, the channel to involve external partners. It's clear that we would like to receive messages and to be involved from the community, the ecosystem, to understand that the technical content they are able to provide, to put together in new activities. Also in the spillover actions, we are the target to deploy new projects and new activity, deploying the results arriving from the Workstreams, the technology, the components, area of activities. So everyone in Europe is welcome to collaborate. And the key point is about content. The content must be clearly in line and aligned with the strategic challenges we have defined and put from the beginning in the description of the chapeau text, the different projects and so on, and the different challenge addressed by each participant project portfolio in an integrated way. So welcome to respect, to maintain the original target we have in the chapeau text.
Okay.
Yes, thank you. I think this is quite a good question, because also it addresses a little bit what the IPCEI is doing, and when we do these kind of webinars, when we actually make it visible what all the partners are doing in the projects. So it's like a showcase, it's like an advertisement. What each company is doing, probably that's normally not so much known in detail to the public, even to some experts. So I think once you see, hey, I have a clever idea, I have a good solution that might fit into what this company is doing in IPCEI, why not addressing this company? I think hope I can speak for everybody, but at least from our side, we are always interested to learn how we can improve our solutions, how we can improve our products. And so I think most of us are open for collaboration. And if this is done because people know of what we are doing from IPCEI, then I think we have reached the goal. So clear, yes.
So I would even say it is already happening, because I already got emails like from an SME working in Czech Republic stating like, I know that this partner is working together with you, how can we collaborate together? So it is already happening, and I think we're very open to that. And the second element of this question to me is like, we see a lot of evolution in the open source community, and I think open source is also an important element of the IPCEI program. And I think in the software world, it's already well known, but also now in the hardware world, it becomes more and more important to work with open source, like RISC-V, like other IP. And this is also an important element in the IPCEI program, where we invite people to really contribute and to work together with us.
Okay, so you are talking about like becoming a participant or partners. If the second question, if I'm not direct or associated participant, what type of cooperative actions can I enter into with IPCEI for direct participant? I mean, connected with the actions they are performing or enabling a further diffusion of those actions. Like, what can I do?
Okay, there are several ways. First, every time one of the partners or a group of partners is creating an event, you can participate, and you maybe in some operations you can make a communication also maybe in these events if you contact us sooner enough with regard to the event organization. That one way. There is of course this patent licensing issue where you can benefit at reasonable price, I would say, to IP generated by us, by all of us. What else? Of course, we can maybe also, because we have taken commitment already with some participants that are external to the program to have cooperation with them, but why not joining also already existing cooperation? That's also a way, I think, it has to be discussed project by project.
This is clearly the way and the difference if you compare the first IPCEI Microelectronics and the second one. Because in the new point in the second IPCEI Microelectronics is this large area. We were talking about the number of other indirect participants. The other indirect participants is really a perimeter not defined, open to new entry, to develop things together, to enter in the ecosystem, to enter in the community, to propose new things, and to evaluate together new events, new opportunity, new programs, new opportunity for project, collaborative activities. This is a clear push we have all together, and the perimeter assigned to the other indirect participants exactly like this. Remain open mind to do a new proposal of technical development activities. And maybe with the enabling role of technologies of microelectronics and semiconductor technology, we will, in a win-win approach, we will reach a new step in different area of technical activities and results.
So as we are talking about spillover activities mostly, are there spillover actions towards, for example, CHIPS GU, Eureka clusters, even Horizon Europe maybe?
Yes, there are, of course, because as you can see, there are joint undertaking is clearly one of the projects. Of course, any project that is matching with Horizon Europe issues and that is that can evolve, in fact, in the IPCEI community is fine. So it's even more than that. I would say that external people that are not in the IPCEI that want to come, we say, okay, I have a project, I would do it with you through Horizon Europe. We just say, fine, just do it. We will make it with you. And yes, so that's part of the spillovers, clearly, yes.
So I would also like to say that if you look to the program of IPCEI versus Eureka versus CHIPS, for example, on one hand there is a complementarity, they do different things, but on the other hand there is a synergy because they do work together. And what I see is that in IPCEI, it's driven mainly by the large industries. There is an important participation by RTOs and SMEs, but if you look to the other programs, they are often much more focused projects, smaller consortia with more involvement of SMEs and RTOs, and I think that's the strength that we have these different programs with a different focus, where on one hand we can do other things, but on the other hand we can do things together, which lead to even better results.
Yeah. One other remark is that we have a real European strength, and why? Because this kind of collaborations in Europe we have for decades. This is something you don't have in US, you don't have in Asia, but in Europe we have that, and this was goes back to the 80s of the last century. So this kind of European frameworks that allow companies to come together to collaborate, all of course pre-competitive. That is really something where we really can benefit out of it. And why? Because even more in the next years is because and somehow the technology developments are more disruptive in the past in the sense that companies cannot simply do standalone solutions anymore. You need to collaborate with other companies, with academia, and to bring the big technology regulations, challenges into the market. And we also need here, and this is the reason why we have IPCEI, we also need the politicians, and we don't need one country. We know because the budget here needed is quite high. We need that we have collaborations in the European Union with many countries. Yeah? So this is a kind of learning also from my side that we need many countries, many companies, many collaborations, academia and RTOs working together, because the topics become just so complex and difficult. You cannot do it alone. So standalone solutions will be the past, collaboration will be the future.
Okay. So Thank you. So I know also for the future webinars we are really open to do this type of synergies as well. So that's also an open point for today. I have a last question here, and I see my team has selected more, but maybe you will answer quickly on this because I think we already talked about it. As a participant of IPCEI ME, are you still eligible for other funding? You mentioned joint undertaking, for example. Do you have something to add on this topic?
Yes, you are. Of course, but of course you cannot do the same thing in two different projects. You know, it must be obviously separated. You know? But yeah.
Okay, so I see we have some more questions from the audience. Thank you, Diane. Okay. So the next one is, what exactly is the role of indirect participants and how are they supported by the program?
Maybe I can take it. Well, when we prepared the building of the projects of each participant program of activities and so on, and just to integrate the big picture in the chapeau text, we have defined, each of us had a list of preliminary possible indirect participants to be involved in activity. Maybe starting from the traditional perimeter of area of activities and collaboration. That's why I told before it's an open perimeter. There are a preliminary list of indirect participants that was proposed and provided by each direct participant, but clearly the collaboration is not fixed. The names are not fixed. There is a way to enter in contact and then define the right way how to cooperate in a project, in a direct bilateral technical collaboration and so on. That's why we started with a preliminary list in different countries, but we understand that at the end we will have a huge number of indirect participants and maybe in a larger number of countries. Sure.
Yeah, maybe also to add a little bit from our Workstream experience right now, is, I mean, when you look into what we develop in IPCEI, it's going close to the product, to an implementation at the end. So usually when you do that in companies and we want to sell our products, you usually talk to your target customer. That's an important step, right? Because you need to have the right solution, the right product for this customer. So I believe even in this discussion, associated partners are very important because they can also contribute, for example, to the requirements, to the KPIs that you need to fulfill for projects, so that you get this information from the whole market. And that's why I think we have quite a large group of associated partners in the IPCEI, because at the end of the day we need to contribute to a market and we need to contribute to a large group of users, and from all those users we need also to find what they really need, to find out what they really need, what are their requirements. And I think this discussion even is a good step in an association to a direct partner that is at the end responsible for the project which is funded by the IPCEI.
Okay. So if there's nothing to add, I have a last question from the chat. It's more about trainings. So Cosimo, you mentioned before to start early. Does that mean that IPCEI participants could and will organize demonstrations at school, for example?
Clearly, yes, we are in French, bien sûr, but because this is one of the push we're receiving also from the public authorities, the European Commission. The targets were originally to impact on students from university, bachelor degree, master degree, and then the PhDs and so on. But really, we understand that we need to start from the early stage of scholarships. So we need to explain and to talk about electronics, microelectronics in a very easy way and a fascinating approach. Also to students in high school. We have several programs with high school, but maybe we need to start just before to show with some educational kits, some training kits, just a game to show how this game inside there is enabled by electronics. This is the challenge for all of us. This is the way to be able to have results in a certain period of years and so on, maybe we hope within the total duration of this IPCEI, to collect a number of interest from school, from high school, also from early stage students that can express an interest to move and to enter in this world.
Okay.
And I think this is already happening in practice. We see there is a lot happening. There are a lot of organizations like non-for-profit centers which role it is in a certain country to stimulate technological education in lower schools, middle schools. And I think we as industry, we need to support this, otherwise this will not work out. And I think IPCEI is an ideal framework to really get the support towards the initiatives that often are already taken, but which require further extension and further in-depth working out what exactly to do to get children in touch with electronics, as you said, Cosimo, and to have them feel what electronics mean. Or just by opening a smartphone and look what is inside, for example. People don't know that, children don't know that. And if they look at it, they are interested, they have an interest, and they are keen to learn about how is this possible. And that is what we need to stimulate.
I may want to blend in because earlier I said we have all the cool stuff as a target, right? Like artificial intelligence and so on. But today what we see also in media is that it's always the highest layer usually that's touched by these technologies, right? But what we can do in IPCEI is to bring down the interest that without microelectronics, the whole thing with AI will not be taking off, right? So, and I think this is what we need to probably have more explained in early stages. Thank you for that, Cosimo. I think that is very important. And I think the companies that are in IPCEI are committed to do that, because this is at the end, as then Ferdinand said, this is our future of talents that will probably make things happening that we have been only dreaming of.
Thank you. So this was the last question. For a question that hasn't been answered, we can answer them later in the comments of the replay of this webinar, which will be available. You can also join the IPCEI through LinkedIn and also the website. So as we approach the end of today's webinar, I want to thank everyone for joining us, so here and also online. We have covered many important topics today. From the strategic importance of the IPCEI ME for Europe's technology to the specific work streams driving innovations in semiconductors. I'm excited to share that the final version of the IPCEI website will be ready by the end of July. So this will be also a key resource for everyone interested in the IPCEI ME program even. On the website, you will find a news section to stay updated with the latest developments. We'll be updating it every week, as for LinkedIn, with news from the project, the programs, and our partners. The website will also have a calendar with information on upcoming webinars, conferences also, and other events related to the IPCEI ME. Our partner can also list their own events here too, so providing greater visibility to the community and the ecosystem. For those looking for job opportunities, training opportunities in the semiconductor industry, the job board will be really helpful, I hope. We will post job openings from various partners, and partners can also post their own job openings to attract talent from across Europe and even more. So yeah, one of the unique features of the new website is that it will be open for contribution, as the IPCEI is open for new partners. So from our partners, but also the whole ecosystem for semiconductors. Whether it's news, events, or job postings, a partner can share their content to be featured on the site. We hope this collaborative approach will keep the website dynamic and relevant, reflecting also the diverse activities you presented today and the diverse opportunities as well. We will continue to organize webinars and events to foster communication and collaboration within the IPCEI ME community. So I can also announce that our next webinar is planned just before the General Assembly, right? Between mid-October and mid-November. So we encourage you to join us for this event to learn more about the progress of the IPCEI ME program and the future plans as well. In closing, I want to thank again all your speakers for their insightful presentations and all participants online for your engagement. We hope the information shared today has given you a better understanding and view of the IPCEI ME program and its opportunities. We will share the replay of the materials, recordings, everything from today's webinar soon, so you can revisit the discussions and share them with your colleagues. If you have any question or need more information, please reach out to us. Maybe this is the last opportunity for you to say a final word, if you want. If not, I can thank you once again for your participation. We look forward to seeing you at our next webinar and working together to drive innovation and growth in Europe's semiconductor ecosystem.
Thank you for hosting this event. It was a pleasure for all of us.
Thank you. So thanks everyone. Thank you online. See you soon and have a great day.